Next up, we have Robert or Bob Sabie, and I'll actually bring up your presentation this time. And Robert Sabie is a research scientist at the New Mexico Water Resources Research Institute and manages the Institute's GIS lab. His research focuses on using geospatial tools and analysis to address a variety of water management problems. He's completing his PhD in water science and management at New Mexico State University and holds a master's of applied geography, also from New Mexico State University, and a Bachelor of Arts in environmental policy and planning from Western Washington University. So, thank you.
Adjust that a little bit. What a great room to be speaking in. There's so many people. People on the floor. That's the first time I've presented in a conference where there's people sitting on the floor. So hopefully this information is really useful for you. Thanks, Nick, for the introduction. I'm Bob Sabie. I'm a research scientist at the New Mexico Water Resources Research Institute. We're at New Mexico State University in Las Cruces, New Mexico. I'm representing a team of researchers from New Mexico State that's part of the Secure Water Future measurement team. And today I'm presenting two of our graduate students' research, Zada and Liam, on their comparisons of OpenET to Pecan and Alfalfa field measurements in the Mesilla Valley. And so at the end of the plenary session, we heard that there's going to be a lot of these case studies coming out, and so there's two of them that are on their way to publication here soon. Just to give you an idea about the region, we're located in southern New Mexico, the Mesilla, Rincon, Hatch Valleys. I kind of lumped those all together, but most of the research that we've been doing is in the Mesilla Valley. And the Mesilla Valley is in Doñana County. There's about 4,000 square miles. There's about 75,000 acres of irrigated agriculture, and the main crops there, pecan, alfalfa, chili, onions, and cotton. New Mexico ranks first in chili pepper production, so while you're here visiting, go get your green and red chili. Second in pecan production, and fifth in onion production. Some of the driving issues, of course, like many places in the western United States and dry lands, experiencing prolonged drought, which we're dependent on the surface water runoff from the mountains and snowpack in southern Colorado and northern New Mexico. And so we're seeing low reservoir storage. This is a photo on the right, I guess it's right, yeah, from that I took in 2022 when Elephant Butte was at about 11% capacity out of the 2 million acre feet that holds. And in times when there's no surface water, the irrigation is supplemented with groundwater, and so we're seeing some groundwater depletion. Another, I don't know if it's really an issue, but it's definitely something that's changing. We're seeing over the last couple of decades a change from row crops and cover crops to orchard, pecans and grapes, and maybe to a lesser extent, maybe some pistachio. So what that does, and Emily will talk a little bit about this in her talk, is it changes the flexibility in management strategies. Another thing that I'm not an expert on, but it's certainly something I have to mention, is that we've been, in New Mexico, we've been in a lawsuit with Texas and the United States over the deliveries on the Rio Grande. And so that's another issue. So there's expected to be some reduction in water use coming from that. But with all these issues, farmers and water managers in the state need all the tools they can to help improve ET estimates and improve management. We think that OpenET can be one of those tools that's in the toolbox. We have several ongoing studies, but the two that I'm presenting today are comparison studies on alfalfa and pecan. So the objectives were to do comparisons between OpenET and field measurements from the eddy covariance towers that we had installed in both pecan and alfalfa, and then identify OpenET models that have the best agreement with the field measurements. And just to understand how that the relevance is, that's about 67%, or about 2/3 of the irrigated acreage in the Mesilla Valley, those two crops. So to hop right into the pecan study, the farm that we had was 4,000 acres, about 180,000 acres of mature pecan trees, all 60 years and older. Those were irrigated using flood irrigation flood of surface water and supplemented by groundwater. The eddy covariance tower that was used was installed and operational between 2004 and 2005 growing season. And as you can see, we also have a big mesa off to the west, and really some dry lands up there. So the methodology, of course, OpenET doesn't go back to 2004, 2005, but what we did is we used the crop coefficient method. So we took the 2004 data, 2005 data, and used the reference ET from a nearby weather station to calculate the crop coefficients. Those crop coefficients were averaged for those 2 years to create a nice crop coefficient curve that was locally calibrated for that orchard. The crop coefficient curve, we used that to calculate daily ET through the 2017 and 2021 growing seasons. So that was 60 months data. Those were the daily were aggregated to monthly, and then the comparisons were done on a monthly time step. So these results actually seem very similar to some of the things that we saw this morning in the plenary session. Out of the 6 models included in OpenET, Sabie had the closest 60-month average with an R-square of about 0.94. Out of all the models, including the ensemble model performed the best. So that's good evidence that supports the use of the ensemble model and approach. In terms of mean bias error, over the 60 months had, was it point or negative? Well, 3 of the models underestimated and 3 of them overestimated. And then the ensemble had a mean bias error of about 6.7 millimeters per month. RMSE, those are similar, and I poked at the paper that was presented this morning yesterday, and so the RMSE is very similar for the results from the Pecan study. So I'm going to hop over to the Alfalfa study. We had 3 fields that we looked at for the 2017 growing season. Willie Joe's alfalfa field was about 90 acres. That had the eddy covariance tower installed in the middle of the field. And then we also had 2 other fields, research fields on different plots on campus, or part of our campus, that we used nearby weather stations and a crop coefficient to calculate the ET for those other 2. So the results for that study, all models except for metric underestimated ET. We looked at that at daily, monthly, and seasonal. 2 of the models in OpenET were statistically different from the field measurements, and that was the SSEB and the dyslexia model. If you look at that seasonal NBE error, one thing I want to point out, I know that OpenET sometimes can kick one model out, and looking at the documentation, there's note of maybe some situations where the better performing model might end up being the outlier, and so this might be one of those cases where metric is actually performing potentially the best out of all the models, but might end up getting kicked out if it were an outlier. So something to consider. So alfalfa did not perform as well, or the OpenET did not perform as well in alfalfa as it did in pecan. So the seasonal error for these 3 were three models were within 10% of the seasonal error compared to the field measurements. So metric, the SIMS model, and ensemble. Those 3 models perform pretty well. Of course, when you get down to like monthly and daily, the errors on those are pretty big on some of those models. So some discussion and next step. OpenET models for these 2 sites showed strong correlation with the eddy covariance measurements at the monthly time step in both pecan and alfalfa, slightly less accurate in the alfalfa. One thing that we were thinking about with that is that there's a lot of gaps. Even though in southern New Mexico we have a lot of cloud-free days, in the 2017 growing season, I did a I looked at Landsat 8 data, and I have a crop coefficient curve from the eddy covariance tower, and so you can see we had 6 different cuttings, and there were only 10 Landsat scenes that were cloud-free during that year. And so I also have the Sentinel data plotted up there as well from the HLS harmonized Landsat Sentinel data set. So that might be one thing that needs to be improved. Of course, there are discussions this morning about data fusion and data harmonization, including more satellites. Another thing to point out is that growers want the ability to see their management decisions reflected in the models within a couple weeks. And so kind of like I think what's driving a lot of these comparative studies is that everyone wants to see how well it performs in their particular field. And so I think that growers are going to do the same thing. They're going to go out and look at their specific field and see if they judge that as accurate or not. So I think that's something to consider. And then I guess just a final thought is maybe inclusion of some of these other harmonized data sets and being useful for filling in some of the gaps for the clouded days. So with that, I ran faster than I thought I would, so I have time for questions.
Hi, Robert. That was a great presentation, really interesting. I noticed that a lot of your sites were surrounded by like hot, dry, barren land. And I was curious if you've given any thought to the footprint of your eddy covariance or warm, dry air blowing over these irrigated systems and causing issues with advection and just increased energy into the system. So it might lend itself to explain some of the error that you're seeing, and it might not necessarily be an error in OpenET, but some of the measurements on the ground. And I say that because we're kind of seeing the same thing in California in some of our sites. So it might be worth looking into, or if you have looked into it, be happy to hear.
Yeah, so I'm presenting other people's work, but I know just a little bit about some of the previous work. The 2017 Alfalfa study, there's a paper that came out, I think in 2021, and they did a comparison between, they measured all the components of the water budget and then compared that with the eddy covariance tower and had pretty good agreement on, inflow, outflow, deep percolation. So that I think they calibrated that pretty well, but I don't know about the Pecan study. But yes, we have a lot of issues with the advection from the mesa and dry area. But thank you.
Hi, thanks. That was great. In California, in southeastern California, where I've been working, we have seen something very similar, which is for irrigated alfalfa, metric is very often the highest of the OpenET models, so high, in fact, that it is getting rejected from the ensemble estimate. And yet, it seems to be the one that is most accurately capturing the true ET, at least for irrigated alfalfa. It's giving us numbers that seem to make sense in terms of the water duties that we would expect from alfalfa. It's giving us numbers that compare favorably with flux tower data. So not so much a question, but just sort of a confirmation of what you've also been seeing.
Great, thank you.
My name is John Longworth. I work for the Office of State Engineer. I've done a lot of work down in the lower Rio Grande. And I kind of have a same question, or I have a question on that. It's being promoted to use the ensemble because the ensemble statistically comes out right? So it has offsetting errors. But I'm curious, why don't we look at the methodologies and what they're designed for rather than just averaging stuff to offset technology? So, I mean, metric is an alfalfa-based sort of approach and in some ways calibrated to that. And so I'm curious why you're promoting using the ensemble, particularly in pecans, which have a lot of different challenges in terms of entrainment, of energy, and those kinds of things, versus actually looking at maybe some of those methods that are part of OpenET that are more geared towards irrigated ag in the arid West?
Okay, so I guess we're just looking at what was comparing with the flux tower. You know, how those compared with the flux tower. But I guess as far as advocating for any particular model, I mean, in this case, the ensemble happened to perform slightly better, statistically better than the other ones. I think that, you know, I haven't looked at the manuscript that Zada's putting together, but I think that she did that comparison between the different models to see if there's any statistical difference or if there's just variability in those, and that's the only thing that's making those different in the R-square values. But yeah, I think that it's worth looking a little closer at some of those other things for sure.
Yeah, I appreciate that because you could do it in the reverse. How could other methods that aren't designed for that kind of application produce results? So I think your comment's exactly on point. Let's look at sort of more the microclimates and what's going on in those localized areas. And this goes back to the plenary session of verifying, trust and verify.
Thank you.
That was a very nice presentation. Thank you. Appreciate it. You indicated that management decisions, reflected in the model outputs, would be really nice to have. I was wondering, what you really mean? Can you please elaborate on that? Second thing, especially for the Pecan, I agree with the speakers asked question before, completely 100% agree with what they say. I will take the time, redo the analysis for the Pecan, just because of such a complex system, the microenvironment, all the biophysical variables, the processes. Again, it's not as simple as alfalfa. Thank you.
Right, thank you. So I guess further elaborate on it's more of an anecdotal situation. I had a conversation with one of the growers in the valley who is probably one of the more early adopters of different technologies. And, this was several years ago, and we were trying to talk about different tools that might be useful for their operation. And he said, I'm not going to trust any absolute value that I get from any tool. But what I will trust is if I can make a decision and then I can visualize how that decision is manifested in some of the satellite imagery. So that's one way that, at least one grower is thinking about how to use the tool, not necessarily for measurement, but for, seeing if there's some kind of response for what he's doing in his operation.
Hi, Robert. Thank you. Great job. Great presentation. My name is Danny Foley with the USGS. I'm interested in looking at various row and orchard crops for evapotranspiration, and I think it's a bold move that you went with alfalfa. Alfalfa can be tricky as it has about the 30-day growing cycle, and I've noticed that in my work that it's rather challenging to work with alfalfa. And I noticed you had in your slides something about you could miss some satellite images in a month due to cloud-free images. And it's important, at least in my research, to communicate with farmers if you can to know when they plant and when they harvest, if it's the beginning of the month, middle of the month. So can you just speak to overcoming some of the challenges of working with alfalfa as it is such an important water-consuming crop?
Well, I guess first, it was more of an opportunity because we had already had the instrumentation installed. So once the OpenET came out, I was like, well, where do we have eddy covariance data for? So I think the decision to do that originally was because it is the second largest crop in the Mesilla Valley. There's fortunately when we did that, we had a farmer that was very cooperative in letting us install the instrumentation. We had a profile of soil moisture sensors. We had a well piezometer in there and had flow measurements, so we were able to do all the components of the water budget. but then, I guess this is more just talking about that specific site, but we had an irrigator, the person he hired for irrigation, who didn't want to share the flow data, and then all of a sudden it becomes really tricky. And this is more just like working, with different farmers, but it became challenging because then it is hard to know, like they wouldn't tell us when they were going to cut or when they were going to irrigate, and so we were going out to the field, a couple times a week just to check on things to make sure we weren't missing those major events. I don't know if I answered your question as thoroughly as you were hoping, but
Yeah, so just to provide some more insight on it, OpenET is a monthly product, and it's all variable and when in the month it's harvested. So thank you for that.
Thanks. Nice talk. I'm Josh Fisher at Chapman University in Hydrosat, also on the tech team for OpenET. I wanted to kind of respond to some of the comments that John Longworth and Kyle had raised. And, for John's point, why promote the ensemble value versus a model that's potentially better? And then John was saying, you could dig into the mechanisms. It's not always about the mechanisms. Related to Kyle's point, there are site conditions. So it could be that E metric is performing well at these site conditions, but not necessarily in alfalfa at other site conditions. And a lot of it is due to the heterogeneity of the landscape, which is what Kyle was bringing up. So some models are more sensitive to some of the inputs than others. And if those inputs are in error because of advection, because of representation, then that model might be in error at that particular site, but potentially perform better at other sites. So the moral of the story is that while a given model might be performing well at a certain site, it doesn't necessarily mean that it's going to be the best model for that particular crop at all sites. And so the ensemble value continues to do well. But it was really also just nice to see the results. Those look really good. And it's great to see that there is a lot of value and still room for improvement and scrutiny and investigation.